In this video, we will demonstrate how to set up the coupling between Ansys Rocky and Ansys Motion. The coupling between Ansys Rocky and Ansys Motion allows for advanced simulations that consider interactions between moving geometries and particles. This helps predict deformations, forces, and realistic system responses. Rocky has a built-in motion solver, but it only allows predefined movements without real interactions between geometries. By coupling with Ansys Motion, we enable geometry-to-geometry interactions, making the motion more realistic and physically accurate. The coupling works by exporting an FMU file from Ansys Motion, which contains all the motion data. Rocky then imports this FMU, applying the motion while calculating forces and interactions with the bulk material. This two-way exchange ensures an accurate simulation. First, open the Ansys Motion preprocessor and create a new standard project. In this case, set the direction of gravity to -y. You can reduce the size of the icons to improve the visualization of the geometry. Go to the Body tab and Import CAD, and look for the assembly geometry. Next, you must create constraints on the geometry connections. In this example, the revolute constraint is being created. Create the other appropriate connections for the geometry using the revolute, translational, and fixed constraints. After creating all the constraints, go to the subsystem tree and right-click on each constraint and select Properties. In the Properties tab, create the motion function for the respective constraint. For more information on how to create the motion function, refer to the Ansys Motion documentation. Then, access the Simulation tab and type the appropriate total simulation time and time step. Click on Run to see the movement created in the Ansys Motion postprocessor. Next, go to the Co-Simulator tab and click on Generate Information. In the Ansys Rocky coupling window, two options will appear for each geometry, input and output. Select output for exported geometries that do not interact with particles in Rocky. These bodies provide position and velocity information to the simulation. Select input for exported geometries that interact with particles in Rocky. They receive forces and moments resulting from the simulation and can modify their behavior based on these interactions. Then, save the FMU file. This file contains all applicable geometries, motion definitions, and motion solver files needed for coupling. In Ansys Rocky, go to Modules in the Data Tree and activate the Multi-Body Dynamics FMU coupling module. In the Module tab, click the FMU File Name button and import the FMU file saved in the previous step of the lesson. The Communication Step Size Control option defines how Rocky and Ansys Motion synchronize their time steps, and three options are available: automatic, manual, and Rocky time step. In this case, we will leave it on automatic. It means that for each time step in the Motion tool, Rocky computes 100 internal steps. Next, right-click on Geometries and select Import Wall. Select the same FMU file imported by the module in the previous step. Select the scale of the geometry to be imported, and all geometries selected in the Motion FBU export process will be imported. It is also possible to insert other geometries, in addition to those imported by the FMU, in this case importing geometry 15. To improve visualization, we will change the transparency of the geometry. In this case, we will create a custom polyhedron particle and a volumetric inlet. For more information on how to create them, refer to the Rocky User Manual. In the Solver tab, edit the simulation time duration to correspond to the total time set in the motion, as well as the time interval. In this case, must be equal to 25 divided by 100, set in motion. The time interval of Rocky could be similar to the time step used in motion. Select the GPU or CPU hardware in the General tab and run the simulation. You can see the interaction between particles and geometry, as well as create cases with interaction with SPH. You can also post-process information from imported geometry and plot data, such as force, for example. Be sure to watch the other 3 videos in this couplings course. By integrating Ansys Rocky with other powerful Ansys software, you can make the most of multi-physics simulations.